Welcome back. In the last lecture, we have seen the procedure for determining the fundamental component and other harmonic components of a given signal using full cycle window based DFT algorithm. So now we will try to solve a problem on this particular method. Coming to the question, if you carefully see, consider a current signal which is having 50 Hz fundamental frequency. This is F0 and the frequency is sampled at 800 Hz. This is Fs. Calculate the fundamental and the fifth harmonic components from the sampled signal, which means that these are the 16 samples which have been collected and these represents the sampled data. So this is the sample number and this is the data which has been taken at that particular time instant. Now, we know that this is the formula which we have developed for determining the fundamental component and also any other harmonic component, where this particular value C is equal to 1 by n for DC component, and for all other sinusoidal things I'll take for 2 by n. In this case, if you see, this is Fs, right, and this is F0. So n is equal to sampling frequency by signal frequency. It is 60. So capital N is equal to 16. So you do need 16 samples for doing this problem. Okay, and here you have been asked to calculate fundamental component and fifth harmonic component. For fundamental component, k is equal to 1, and for fifth harmonic, k is equal to 5. Right? So we will employ this particular data for solving this problem. Now, so let us once again look back at this one. Fundamental component k is equal to 1. So I do require x of 1, which is equal to, see, for x of k, you know the equation is sigma capital C, sigma n is equal to 1 to, sorry, 0 to n minus 1, right? This is x of n into e to power of, or I can write it as cos of 2 pi kn by capital N minus j sine 2 pi k small n by capital N, right? Here, if I am going for fundamental component, k is equal to 1. And you know, the number of samples we have already seen, it is 16. So this equation gets reduced to x of 1, which indicates it is fundamental component. C, except for DC, for all other components, it is taken as 2 by n, right? Sigma n is equal to 0 to n minus 1, x of n into cos of 2 pi, k is equal to 1 here. So I am taking it as right. So in this particular case, n is equal to 16, right? So I will still modify this equation. This will become x of 1 is equal to 2 by 16, which is equal to 1 by 8, sigma n is equal to 0 to 15, x of n, what will this become? 2 pi by n, right? 2 pi is 360 degrees, so 2 pi by n, which means 360 degrees by 16, right? It is somewhere around 32, and I'll get 62 is 32. So it is 22.5 into n degrees minus j sine 22.5 n degrees, right? So this is my expression. Now I will try to represent it in the form of a Excel sheet. So now so now what we have obtained now, we are going with x of 1, which is equal to 2 by 16, right, which is equal to 1 by 8. Sigma n is equal to 0 to 15. This is x of n into cos of 22.5 n degrees minus j sine 22.5 n degrees, right? This was our expression. Now we try to solve this one. It's better if we go with a table type of thing. Say n value which varies from 0, 1, 2, 3, like this up to 15, right? And x of n, this is also the data which will be given for you. So these two are your given data. Now what you will be doing is you will be calculating first of all CW, which is equal to your, in this case it is cos 22.5 n. Right, n value will be varying from 0 to 15. So here in this case it is cos 22.5 0. It is 1. In this case it is cos 22.5. You will get some value. Here it is cos 22.5 into 2. It is some other value. Next cos 22.5 into 3. This is something. This is cos 22.5 into 15. Right. Similarly, I'll calculate SW, which is equal to my sine 22.5 n. Okay, so which is nothing but in my case it is sine 0 is equal to 0, sine 22.5, sine 22.5 into 2. This is sine 22.5 into 3. Like that it will be varying. And this is the data which has already been given for you in the, I'll show you now. Yeah. This is the data, 14.1, 9.2, 6.8. Yeah, this is 14.1, 9.2, 6.8, like that. This is the data which has already been given for you. Right. So now what I'm doing is, here I'm doing CW into x of n. I'll multiply this equation and here, and I'll write it here, which is equal to 1 into 14.1. Next here, whatever the value which I will be getting, something into 9.2. Next into something into 6.8. So I'll multiply these two and I'll write down here. Similarly, what I'll do is, I will multiply SW into x of n. So next time I'll multiply this one and this one. Right, so 14.1 into 0, 9.2 into whatever value which you have got here. So like that I'll be doing for my entire set of values. Once I get, I'll take the sum of all these things. If I get, let us suppose A, and if it is B, so my I of 1, which is nothing but my I fundamental, is equal to A minus JB. If I take this magnitude and this is angle, this is the magnitude of I fundamental and this is the angle of my I fundamental. Now I'll show you. See, I have done this one. See, these two are the data which is given for me. Right? In this case, see, this is cos 2 pi n by n into k, where k in this case is 1 in this case, and n value is 16 in my case. So n value, small n value, it will be varying 0 to 50. Similarly, this is sine 2 pi by n capital N into k. Once I do it, so this 2 multiply and it has been brought here. Next thing is these two will be multiplied and it will be brought here. So once it is done, see, the summation of all these things, it is 80.055, and the summation of all these things, it is minus 0.103. Right. So here, earlier it was there 2 by n. 2 by n is 2 by 60. And the summation of all these terms, it is 80.055 minus say 0.103. So if I solve it, I'll get this is the value. So approximately this is somewhere around 10 minus j0. So I can write it as 10 at an angle of 0. This is my fundamental component. Now, if I want to compute fifth harmonic component, what I should do? I should take k is equal to 5. See, for harmonic component, k is equal to 5. So, what will happen now? The CW, which was there, this will become, see, 2 pi by capital N, k, n small n, right? So, in this case, k is equal to 5, right? So, what will this become? This will become cos 10 pi by capital N into small n, right? What is this one then? 10 pi is, pi itself is 180, 10 pi is 1800 by capital N is 16, right? So, in this case, it is, how much it is? 1800 by 16 cos 1 and again you will get 1 and 2.5, right? So, this is decrease. Similarly, what will be SW? It will be sine 112.5 n degrees, right? Where n value will be varying from 0 to 15. Now, if you carefully see, this is given data and this is also given data. CW we have seen, right? It is cos 112.5 n. Here it is sine 112.5 n. N value is varying from 0 to 15. Here also n value is varying from 0 to 15. Next, how this column is obtained? You multiply these two, you will get this one. And you multiply these two, you will get this value. Once you get all these things, this is your summation and this is your summation. Right? So, see here. 2 by 16 minus 0.151 minus say 7.77. So, if I take solve this one and see this is my value, right? So, if I solve it, I'll get this is somewhere close to 0. So, I'll take it as 0 and this is somewhere close to 1. I'll take it as 0 minus C1 approximately. So, which means that my fifth harmonic component is 0 minus C1, which I can write it as 1 at an angle of minus 90. This is the magnitude of fifth harmonic and this is the phase angle of fifth harmonic. Right? So, I hope you have now understood how to compute harmonics and also the fundamental component or the DC component from a set of given sample data. Now, if you see the full cycle DFT, it uses samples of one full cycle duration to estimate the phasor. And the second sentence here, it represents a formula of your x of t. And not only the fundamental component, you can determine the harmonic components also, along with the DC component also, which was not possible with the help of your earlier sinusoidal based components. So now, I hope that you are able to determine any harmonic components of given samples using full cycle window based DFT algorithm. So this is your problem. Try to solve this problem. See, calculate the DC, fourth and fifth harmonic components. Fifth harmonic component, I have already done this. So you calculate DC and fourth components and get back to the class. Thank you.